Hello children, today we will start new chapter number 6, study of first element, that is hydrogen. So as we all know that the symbol of hydrogen element is H, its atomic number is 1 and also mass number is 1. So hydrogen is having 1 electron and 1 proton. Okay students, but number of neutrons equals to 0. So hydrogen is only the element in which neutrons are not present. First heading is position of the non-metal hydrogen in the periodic table. So as you can see in this periodic table that hydrogen is placed both in group 1 first period and group 17 first period. Okay, so hydrogen is showing dual position in periodic table. It is placed with strong metals which are known as alkali metals in first group. So hydrogen is placed with alkali metals in periodic table, and also it is placed with strong non-metals halogens. Okay students, so hydrogen is placed in 2 different groups. In first, it is placed in first group with alkali metals, and in second, it is placed with halogens in 17th group. So it's having dual position due to its dual nature. The next heading is position of hydrogen in the periodic table. So as I have already told you that atomic number of hydrogen is 1 and number of valence electron are also 1. So it is the first element of the periodic table placed in group 1, period 1 of the periodic table. Next heading is dual nature of hydrogen. So hydrogen is showing dual nature. It is showing a resemblance in properties with the metals of the first group, and in some other properties it is showing resemblance with the non-metals or halogens of 17th group. So first heading is hydrogen has the simplest electronic configuration of 1 and hence either loses 1 electron behaving like electropositive alkali metals. So just 1 electron in hydrogen in is to 1 shell only. So hydrogen with 1 shell carrying 1 electron, so it can lose this electron and converted itself in the form of ion which is carrying unit positive charge as rest of the alkali metals are showing. Okay, so by loss of 1 electron, hydrogen can convert itself in the form of unit positively charged ion as other alkali metals can do. Okay, for example, lithium can be converted itself in the form of lithium ion and sodium in the form of sodium ion by the loss of 1 electron. So same way hydrogen can also lose its 1 electron and converted in the form of unit positively charged ion. Second point, gains 1 electron behaving like electronegative halogens, group 17 element. So by gaining 1 electron, hydrogen is converted itself in the form of hydride ion. And in the condition of hydride ion is having total 2 electrons. So by completing its 2 electron, hydrogen is attaining the configuration of nearest noble gas, which is helium. Okay, so in the form of hydride ion, hydrogen is achieving the duplet configuration or duplet electron condition in the shell. Okay, like helium. So in fluorine is also gaining one electron and converting itself in the form of fluoride ion, and in this way it is completing its total 10 electrons and achieving the configuration of nearest noble gas helium. So helium is having 10 electrons. Okay, same way chlorine also, after gaining one electron, converted itself in the form of chloride ion and achieving the configuration of nearest noble gas argon, 18 electrons. Okay, so like halogens, hydrogen after gaining one electron completing its duplet condition. Okay, then resultant position of hydrogen. So as you can see here, hydrogen is showing two different and opposite nature. In the first nature, it is behaving like an electropositive element, losing one electron, and in second, it is behaving like an electronegative element and gaining one electron. Okay, so these two are just opposite nature, resultant position of hydrogen. So hydrogen thus show similarities with alkali metals of group 1 and also with halogens of group 17, and that is why it is placed above lithium in group 1 and above fluorine in group 17. So because hydrogen is showing two different opposite nature, that is why it is placed with alkali metals in group 1 and with halogens in group 17. Okay students, thank you.